Synthesis and biological study of triazole-based molecules inhibiting factor XIIa. Arterial thrombosis causes over 10 million deaths annually, which is a 30% increase in the past 2 decades alone. Anticoagulants are drugs that can prevent blood clotting. They are used because they can help prevent the chances of stroke, heart attacks, and other heart diseases. Current anticoagulants include vitamin K antagonists, heparin, and thrombin. Warfarin is the cheapest in the market. While they are effective, they also carry the risk of bleeding. They cannot be used in diverse patient populations, and clinical studies have shown that around 7 to 10% of people experience side effects based on the drug that they use. The goal of the project is to design and synthesize inhibitors of factor XIIa, which would create more effective and safer anticoagulants for the prevention of blood clotting. This would help avoid cardiovascular diseases such as stroke, while also limiting the number of side effects the patients experience. Factor XIIa is a trypsin-like serine protease. It activates factor 11 in the intrinsic pathway, starting the clotting cascade. It also reinforces the kallikrein-kinin system. Experiments conducted on factor XIIa deficient mice show that they were protected from arterial thrombosis and ischemic stroke. In addition, they also showed no increased bleeding. These are some of the factor XIIa inhibitors that are being produced in the market. We hypothesized that selective inhibition of human factor XIIa can produce safer anticoagulants that do not carry the risk of bleeding. We also hypothesized that inhibitors of factor XIIa would prevent thrombosis while also leaving the hemostatic process intact. Our approach was to design and substituted triazole-based inhibitors. This is the reaction scheme used in the lab. We used an amine and then reacted it with an acid chloride in the presence of a base N-methylmorpholine to create the product. The product was isolated through recrystallization and NMR was performed afterwards. These are some of the inhibitors that were produced in our lab. The chart shows triazole-based molecule inhibition of factor XIIa. The inhibition was determined using a chromogenic substrate hydrolysis assay. The molecules were screened at 100 micromolar and measurements were performed in duplicates. The y-axis shows the amount of enzyme residual activity, and we wanted the numbers to be low because that would show that the inhibitor that we produced was working. For our future studies, we plan on conducting docking studies. IC50 values will be calculated, selectivity studies will be performed, and more analogs will be synthesized. In addition, new scaffold coumarin-based molecules will also be designed.